We're going to talk about determining whether a relationship is a function. We're going to be using these two examples here. We have two relationships between x and y. By the way, moving forward and generally in mathematics, when you talk about a relation in terms of two variables, x is going to be considered the input or the independent variable, and y will be the output or the dependent variable. But we have the equation, a table of values, and the graphical representations for both of these relationships. Our job in this video is to define what a function is and determine if these are both functions. First of all, we need to define a function. A function, importantly, is a mathematical relation where each input in the function's domain is related to only one output. That's really important. Let's write that down. Each input, in our case, that will be the x's, are related to only one output. And again, the y's are the outputs for our example. When determining whether a relation is a function, it can be difficult to analyze the equations, though it's not impossible. This video is going to focus on analyzing the tables and the graphical representations of these relations. In the first example here, if we want to analyze the table to see whether this represents a function or not, we need to investigate whether there is an input or an x value that's related to more than one output. As we look through this list, at no point is there an x value that's doubled up and related to two different outputs, though you can see over here that is actually occurring. In this table, the input of 1 is being related to both 4 and to -2. That means this is not a function. A quick note on this is to say these tables are a small number of the actual solutions to these relations, but when I look at this table, I could not determine this is not a function. If this was all the information I had for this relation, I would say that this is a function. Let's now compare that with these graphs. As you can see on the graphs, I've highlighted each of these solutions for both of these relations. Importantly, I want to focus on this example when we found out that x equals 1, or the input of 1, is related to two separate outputs, and how that relates itself to the graph. As you can see the graphical representation of this relation right here, if I draw a vertical line down the input of x equals 1, it is related to both 4 and to -2. In fact, if we are ever asked to analyze the graph of a relation and determine whether it is a function or not, we can use what we call the vertical line test. The vertical line test says that if we can draw a vertical line through two or more points on the graph of a relation, that graph cannot represent a function. Again, if you look at what I've highlighted here, these 2 points, these 2 times where the input of x equals 1 is related to two different outputs, y equals 4 and y equals -2, that is represented by the fact that I could draw this vertical line through this circular figure through both of those points. It's not possible to do the same thing with this first relation. If I draw perfectly vertical lines anywhere on this graph, at no point can I draw a perfectly vertical line through 2 points. That does say that this is a function, this relation is a function between x and y. This relationship is not a function.